So now let us go to the second type of linear inequations, that is multiple linear inequations. So here you have inequation in one line, but there are two inequations. So this is an example of multiple linear inequations. So in this multiple linear inequations, there are two types. The first type is that you have variable only in one term and two terms will be constants. So both of this have variable only in the middle term and both the extremes are constants. So if the inequation looks like this is slightly easier. So what I do is, again, I'll use the concept of linear inequations. I'll use the 4 rules. So first, if I have to do this, so first you have 4 minus 7x by 2 lying between minus 3 and 18. So I'll subtract 4 uniformly on both sides, on all sides. So minus 3 minus 4 is less than or equal to 4 minus 7x by 2 minus 4 is less than or equal to 18 minus 4. So in the middle portion, 4 and minus 4 gets cancelled. So minus 7 less than or equal to minus 7 by 2 into x less than or equal to 14. Now I need the solution for x. So what I do is I'll uniformly multiply each of this side with minus 2 by 7. So minus 7 times minus 2 by 7 and 14 times minus 2 by 7. And if I multiply minus 7x by 2 with minus 2 by 7, it becomes x. Now I have multiplied each of this side with a negative number, so the sign of inequality changes. So it becomes this. So 7 and 7 gets cancelled, 7 and 7 gets cancelled. So minus of minus 2 is 2 greater than or equal to x greater than or equal to minus 2. This implies x lies between minus 2 and plus 2. That's the answer to this inequality. That's the solution to this inequality. Next, if you go to the next inequality. So minus 12 is less than or equal to 4 minus 3x by minus 5 is less than or equal to 0. So I'll uniformly multiply each side with minus 5. So minus 12 times minus 5. So if I multiply this with minus 5, it gets cancelled. So you have 4 minus 3x. And 0 into minus 5 is 0. So does the sign of inequality change or does it remain like this? It changes because we are multiplying with minus 5. So less than or equal to becomes greater than or equal to greater than or equal to. So minus 12 into minus 5 is 60 greater than or equal to 4 minus 3x greater than or equal to 0. You can uniformly subtract 4. If you uniformly subtract 4, it becomes 56 greater than or equal to minus 3x greater than or equal to minus 4. And if you uniformly divide with minus 3, 56 by minus 3, x minus 4 by minus 3. So according to the rules of linear inequalities, the sign of inequality changes. Right? So minus 4 by minus 3 becomes 4 by 3. So x lies between minus 56 by 3 and 4 by 3. So that is the answer to this question. Thank you. So the next type in multiple linear inequations is a linear inequation which contains variables on all sides. So you have variables here, here as well as here. So now how do we solve this? So we solve this like we solve two questions. So this is effectively two questions on linear equations. So what we do is we first solve this part of the linear inequation and then we solve this part of the linear inequation separately. And once you get two solutions, we find the simultaneous solution. So to do that, what we do is first let us take this part. So 2x minus 5 is less than or equal to 4x plus 7 by 2. So I'll bring 2x onto this side and 7 by 2 here. So 4x minus 2x is 2x is greater than or equal to minus 5 minus 7 by 2. This implies 2x is greater than or equal to minus 17 by 2. If you take LCM, you get minus 10 minus 7 minus 17 by 2. So this implies x is greater than or equal to minus 17 by 4. So this is the solution for the first part of the linear inequation. Now let us solve the next part, this part. 4x plus 7 by 2 is less than or equal to 2x plus 18. So 2x, I'll send it on to this side, 7 by 2, I'll send it there. So 2x is less than or equal to 18 minus 7 by 2. That is 36 minus 7. So 2x is less than or equal to 19 by 2. 2x less than or equal to 36 minus 7 is 19 by 2. So this implies x is less than or equal to 19 by 4. So if this part of the inequality has to get satisfied, x has to be greater than or equal to minus 17 by 4. For this part to be valid, x should be less than or equal to 19 by 4. Now I want both of these sides to be valid. This is a simultaneous linear inequation in which this has to happen and this has to happen. That means my solution should be the common solution for this as well as this. So what we do for common solution is, we plot both the solutions on a real number line. So the first solution is, so let this number be minus 17 by 4. X is greater than or equal to minus 17 by 4. So all numbers greater than minus 17 by 4 are valid for this. Next, let us take this next solution. So you have a number 19 by 4. X should be less than or equal to 19 by 4. So for this equation to be valid, for this part to be valid, x should be less than 19 by 4. For this part to be valid, x should be greater than minus 17 by 4. For both of them to be valid, we have to take the common solution. That is, x is in between minus 17 by 4 to 19 by 4. So that will be the common solution to, that will be the effective solution to this inequation. Now let us go to the second. This is also a similar model. So again, I'll do the same process. So first, I'll solve this part and then I'll solve this part. So if you take the first part, x by 2 plus 6 is greater than or equal to x plus 2 by 6. So if you cross multiply because it's a positive number, you can cross multiply this. So 6 into x by 2 is 3x plus 36 is greater than or equal to x plus 2. So if I bring this x here, so 2x is greater than or equal to 36 if I send on to this side. 2 minus 36 is minus 34. X has to be greater than or equal to minus 17. So for this part, x has to be greater than or equal to minus 17. Now if you go to the second part, 2 plus x by 6 is greater than or equal to 3x plus 4 by 12. So because 6 and 12 are positive numbers, I can cancel this out 2 times. I can cross multiply this. So 4 plus 2x is greater than or equal to 3x plus 4. If I send this 2x here and 4 here, 0 is greater than or equal to x. 0 is greater than or equal to x. That is, x is less than or equal to 0. So for the first inequation to be valid, x has to be greater than or equal to minus 17. X has to be less than or equal to 0. So what is the simultaneous solution for these two inequations? So if you draw the real number line, so one solution says that x should be greater than minus 17. The second inequation, the second part of the inequation says that x has to be less than or equal to 0. So what is the simultaneous solution? X is in between minus 17 and 0. So x belongs to minus 17 comma 0. That's the answer to this question. So in type 2 itself, the last model is direct simultaneous linear inequations. So in this type of questions, you will be given two inequations directly. You just need to solve both of these inequations and get the common solution. Something like 4x plus 3 is greater than or equal to 2x minus 17 plus 17 and 3x minus 5 is less than minus 2. So if you solve the first one, if you bring this 2x here and you send this 3 onto that side, so 4x minus 2x is 2x is greater than or equal to 17 minus 3 is 14, x greater than or equal to 7. This is one part. This is the solution for this inequation. And 3x is less than this minus 5. It goes onto that side, becomes plus 5. 5 minus 2 is 3. So x is less than 1. So if one inequation says that x has to be greater than or equal to 7, the next inequation says that x has to be less than 1. So let us plot both these solutions on a real number line. So if you take the real number line, one solution says that my x has to be greater than or equal to 7. The next solution says that my x has to be less than 1. So what is the common solution to these two inequations? You can see that there is no common solution. Hence, the answer to this question is no solution. So this pair of linear inequations or the simultaneous linear inequations does not have a solution. Now if you go to the second one. So here also you're given two inequations. So you just need to solve these two inequations and get the common solution. So first inequation. So if you take the LCM here, you get 16x minus 27 by 12 is less than 4x plus 3 by 4. This 4 gets cancelled 3 times. Positive numbers can be cancelled out. So this 3 goes onto that side. 16x minus 27 is less than 12x plus 9. So this implies 16x minus 12x is this 12x. If it comes onto this side, that 4x is less than 27. If it goes onto that side, it becomes plus 27 plus 9 is 36. This implies x is less than 9. So this is one part of the answer. Now let's go to the second inequation. Here also I am doing the cross multiplication. So 6 into 7x minus 1, or I'll take the LCM as 6. So you have just need to multiply the numerator with 2. So 14x minus 2 minus 7x minus 2 is greater than x. So this implies 14x minus 7x is 7x minus 4 is greater than 6 can be cross multiplied because it is a positive number 6x. So this implies if I bring 6x onto this side, 7x minus 6x is x is greater than 4. So the solution for this is x is greater than 4. The solution for this is x is less than 9. So what is the simultaneous solution? If you plot both of them on a real number line, one says x has to be greater than 4. The other inequation says x has to be less than 9. So what is the common solution to these two? So x belongs to 4, 9. Thank you.